Back to our first challenge, challenge 1 with the 3 conveyors. You're looking at the logic as we left it. This is part 2. Just for fun, let's jump ahead and use some more timers to create ladder logic diagrams that simulate someone operating the conveyor. We will add this logic after the rungs that you have just created. We're going to leave these rungs right here alone. We're going to add them down below. Now, I tell you to go offline, but you could do this online. We're going to save this as file, save as, and I'm going to make it, I think I'll make it part 2, 00. That's not what I told you to save yours as, but that's what I'm saving mine as. Now, one thing I do on purpose quite often is I don't do things exactly the way I showed you in the manual. That gives you 2 looks at how to do something instead of just one. If I show you something in the manual and then I do it exactly the same, that reinforces that one way to do it. However, if I do it slightly different, and remember that when you did these projects, you should have completed them before you looked at the video. You already know how to do it that way. So if I show it to you slightly different, there's an advantage to that. I do that on purpose. I hope that's not a point of confusion. We will add this logic after the rungs that you just created. We can do this only because we have not aliased our actual module-defined tag members with these tags that we have created. Otherwise, the state of the input members would override our simulation logic. So we're going to add logic that simulates releasing the push buttons. That way you don't have to toggle them on and toggle them off. You toggle them on and then they go off by themselves. You wouldn't be able to do that if these were aliased to input devices. You would have to operate the input devices because you cannot override the state of the input devices, program mode or run mode. First, we'll do the 2 rungs that operate the system enable. We'll do the rung above. We'll do it right above so you can see what we're doing. As a matter of fact, I told you to go offline. I'm going to go offline and add a new rung right above this one. And then I'm going to copy, Control V to put it in there. Then I'm going to go get a timer counter, TON. It added a TON, and we're going to name it Start System Pulse. Start Sys Pulse. We set the preset of the timer to 200. That's 200 milliseconds. See, it wouldn't let me put in 200 because I haven't defined it as a tag yet. It doesn't know what to do with 200. Start. We're going to make it program. Create. Now I can put in 200. And we don't need an accumulate. With the focus on the timer structure, we can go back to our favorites and click on a true if on. Drag that tag over there. Even though that's not a Boolean, it will still accept it in that position, but it would never let you accept the rung. Just double click, and we're going to make that the timer timing pulse. So dot T, and see the other T shows up automatically. Hit enter. That's the Start System Pulse timer timing pulse. And then we're going to do an output energize. I'm going to take the Start System push button and drag it over here onto that. Now this may look crazy to you, but you'll see in a minute how this works. Okay, so that rung is done. When we toggle on this bit, it starts this timer. This timer timing bit is true as long as this is accumulating from 0 to 200 milliseconds. If this is true, remember you toggled this on, so it's on. It doesn't go back off unless you toggle it off again. You toggled it on, timer starts, this is on for 200 milliseconds, this is on for 200 milliseconds, and at the end of that 200 milliseconds, the false execution turns it back off. Now I'm going to do something I didn't do in the manual necessarily. I'm going to download. Now we're downloaded and we're running. I'm going to right click here, toggle. What's interesting is the system is enabled now and the start push button is off, correct? You didn't even see it. Go on. So let's do that again. I'm going to just toggle that off. I'll cheat. Okay. I'm going to, as a matter of fact, let me bump this up to 2000 so you can watch it. Toggle this on. You can see this is all on, and then at the end of 2 seconds this goes off, turns itself off. That's off. You only have to toggle this once, and it gives you a pulse. Now we don't want that 2000 milliseconds, so it doesn't even have to be 200. It could be, we'll make it 1 millisecond to see if it works. I tend to try to simulate what a push button would be if you push the button and release it as fast as you could do it. Okay, see, so 1 millisecond works. But if you think about how fast you can push a push button and release, 1/5 of a second would be pretty fast. So there's the start. Now I'm going to do the stop. I'm going to go back offline, and I'm going to save it as part 2 version 1. We had version 0, now this is version 1. And I'm going to go back to the manual because I kind of jumped ahead. Rung 0 toggles the start system push button. Remember that all of these push buttons are momentary, and they are either normally open like the start push buttons or normally closed like the stop push buttons. To simulate these push buttons, we need to momentarily toggle their states off on off or on off on with the RS Logix 5000 toggle bit feature. In the rung above, the rung that you're looking at on top there, we want to momentarily close the contacts of the start system push button. When you toggle it on, the on-delay timer sets its timer timing bit to 1 for the length of the preset, which is 200 1,000ths of a second, thereby simulating the push button being depressed for 2/10 of a second and released. Or you could say that you toggled it on from your keyboard and the logic toggled it off after 2/10 of a second. Remember that when the logic goes false, the false execution of the OTE sets that bit in memory to 0 or off. This rung is self-extinguishing. We turn that bit on and the rung turns that bit back off. So it's self-extinguishing. This is a nice little piece of logic to tuck away in your toolbox. You might need it someday. And then it comes back to rest as shown. So this is at rest here. Simulating a momentary stop push button. Don't forget to set the stop push button bits to 1 on before you test any of your simulation code. Those bits are always in the on state when the push buttons are at rest, not pressed against the spring return. That's what at rest means, that you're not depressing the spring, it's at rest. Just the opposite of the start push buttons, the stop push buttons are normally closed. Operating them is to momentarily open the contacts. When you toggle the stop push button off, the on-delay timer is going to do the exact opposite thing that it accomplished with this rung. So now let's add in the stop push button. We'll add another rung, right click, copy, Control V. This is going to be a little bit different because we're not going to use the stop button here. Instead, what we're going to do is we're going to use, and there's 2 or 3 different ways to do this. There's probably more than that. So I'm going to have a latch for that stop push button. I'm going to latch that on, and as I do this, you're probably not going to follow it, but that's okay. Then I'm going to branch around We've done this once before. And then here I'm going to have a true if off to get the timer going. I need the timer timing pulse, and then I need an unlatch. So this is the stop system pulse. We'll define that. Main program, timer, see, automatically timer data type because it's a timer instruction. Now you could always change this, but it would mess it up. So it's intuitive in a sense. We can drag this up here, double click. Now we could drill down, okay? See, stop system pulse. We could go down here and double click on the done bit. We could do it that way. And we could do the same thing over here, or we can just drag one of these over here, double click, backspace twice, timer timing bit, hit enter. Okay, that goes there. It also goes here. I know this is probably, well, you've already done this in the lab, so you've already worked with this. It's not like you're seeing this for the first time. I keep forgetting that I'm discussing what you did in lab like I did thousands of times in the classroom with engineers and technicians and electricians, and I would have them do labs like you're doing, identical to these, step by step, and then at some point when it looked like pretty much everyone was done, all right then, everybody pay attention. Let's look up here, and I'd use a whiteboard, use a projector, and I would go through and discuss all this. Just like you're seeing right now, only it would be up on a big screen by way of a projector from my keyboard. But looking at the exact same thing, hearing me tell the same stupid jokes, exercising the same old-fashioned idioms. So this is exactly what you would have gotten in the classroom. But you've already done this, so you've already had some explanation. Just the opposite of the start push buttons, the stop push buttons are normally closed, operating them to momentarily open the contacts. When you toggle the stop push button off, the on delay timer in this rung sets its timer timing bit to 1 for the length of the preset, which makes the bottom branch of the above rung true and unlatches, sets the stop push button to 0 for 0.2 of a second. When the timer has completed the 0.2 of a second delay, it sets its done bit to 1, making the upper branch of the rung true, and latches the stop system push button back to 1 on the very next program scan. The bottom branch is false because the stop push button is now on again. So you toggled it off to get this started. This resets the timer, and the run condition is now false until you toggle the stop push button bit again. So let's download this. Download. Read this if you like. This always says the same thing. The only thing that varies a little is the controller is in the remote run mode instead of program mode. In a non-remote, in run mode, it won't let you do anything. It's got to be in the remote run or program. Download. Downloading. And there we are back in the run mode. Now, this is important to notice. The stop push button is on. And it should be on anytime you're not pushing the push button. It's representing a normally closed contact. Start push button is off. If I toggle the start system push button right here, I don't have to toggle it up here. So these two rungs do not have to be in sight. You can go up here, anywhere you see it, you can toggle it. You see, you didn't see it. We'll do that again. We'll cheat here and I'll toggle that back off. We'll bump this up to 2 seconds. And we'll make this one, whoops, we didn't put a preset in there. We'll make that 2 seconds. Okay, let's do that again. Toggle bit. See, it's on for 2 seconds, then off. Now, watch this. See, that goes off for 2 seconds and then right back on. This toggles it on for 2 seconds. This toggles it off for 2 seconds. When I say toggles, I mean it's a double toggle. You know, toggle on, toggle off, toggle off, toggle on. Okay, so this is good logic here. And this is much more meaty. There's more meat to this on the bone, so to speak, than what you've had so far. And that's the nice thing about the challenges. We kind of loosen up a little bit. We don't try to explain everything in detail. We just throw some things in there to just give you a challenge and just for fun. So sometimes we call these just for fun, and sometimes we call them challenges. In this case, it's a challenge because it's a quasi-practical application. Add this new rung after rung 0. With your logic in the state shown to the left, toggle the stop system push button once. Since it is on, it should go to the off state when you toggle it. Let's change these back to 200 milliseconds. There's no reason to wait that long. As you saw, it'll work with 1 millisecond. But we were trying to, well, that's interesting. I must have fat fingered it. We're trying to simulate a real quick button push. Duplicate these 2 rungs for the conveyor control logic. Each conveyor control has a normally open start push button and a normally closed stop push button to simulate. That means you have to duplicate this code 3 times now. These 2 rungs for conveyor 1, these 2 rungs for conveyor 2, and so forth. Now, you've already done this, so you're just listening to me discuss what you've already done. I'm going to pause, put this code in, and then come back. Before I do that, though, I think I will show you how I'm going to do it as far as time saving goes. I'm going to click on rung 0, then I'm going to hold down the control key and click on rung 1. Now they're both selected. So I'm going to go Control C, Control V, Control V, Control V. Did it 3 times. So I duplicated, I copied that code and then duplicated it 3 times. Now that's one way to get that code in there 3 times. Personally, I wouldn't put it in there 3 times. I'm going to delete, and then I'm going to change just 1 to conveyor 1, then I'm going to come back. Okay, here you are with just conveyor 1 done, so we're going to test it. Ignore, don't operate it up here. Go down to here. System's already enabled, so I'm going to toggle that bit off, and you see it goes right back on after 0.2 of a second. So here the system is at rest. So I'm going to push the start system push button. You didn't really see it go on and off, but it did. Now the system is enabled, and you can see that conveyor 1 is now enabled. So I'm going to hit the start conveyor 1 push button, toggle bit, and you see it's on then back off, but it leaves the conveyor running, goes back off. This is the stop push button. Toggle that off, and it comes back on, and it's ready to start again. So that demonstrates that this code works. These 2 rungs are just for conveyor 1 start and stop push buttons. So we have to duplicate this 2 more times. I'm going to select rung 2 and rung 3, shift 3, Control C, Control V, Control V. Now, all that I have to do is go in here, change the 1 to 2, 2, 2, 2, 2, 2, whoops, 2. Some of these are already defined tags, like these right here, they're already defined. So when I finish, if I then define this as a timer, that's finished, because the only new tag was the stop conveyor 2 pulse, which includes this done bit and this timer timing bit. Now it's interesting that it leaves it in lowercase. I don't like the way that looks, so I always go change it. It doesn't hurt anything. So that's all it took to change this. Now this one, we need to define that timer. And once it's defined, then this rung is good. So we go down here, we do the same thing to these two rungs. Double click, 3. Now that's already a tag. We don't have to define that, but this is going to be a new tag. 3. Then we can new, create, as long as it's in the program. 3 and 3. So some of these are existing tags. Then down here, this will be a new tag. 3, define. Now, you see we have the eyes here. It's a happy rung. But we're still going to go change these to 3, but they already exist. These aren't new tags. Once you create the timer tag, then any tags that associate with the bits show up good. Okay, so this is all done now. So this is conveyor 3. Oh, I missed one. Ooh, how'd that get there? Stop system push button. So that was a mistake right here. And the only reason that it worked is because there was only one conveyor running, so it stopped it because it knocked the system out. That's the wrong tag. I made a mistake. This should have been stop conveyor 1. This tag right here, stop conveyor 1 push button. So we'll drag this up here. See, stop conveyor 1 push button, stop conveyor 1 push button. And so I copy that mistake here too. See, that should be stop 2. Drag it to here. Gotta be careful when you're dragging it. Okay, this would be 3. You gotta be careful where you're dragging it, because if you come down, if you dropped it right there, it would put it over here. So look at the Mimi. Make sure the Mimi is lit where you want it before you let go. Okay, now we can finalize all edits. And we don't need to see any of these rungs up here, the upper rungs. So we're going down to rung 8, 9, 10, and 11. We've got 0 through 7 up there. We've got a bunch of rungs up there, but we're going to operate it from here. Just pretend that this is your logic and these are real inputs. So first thing we want to do is toggle that on. You didn't see it go on, but it went on for 0.2 of a second and enabled the system, enabled all these. So now we'll toggle on the conveyors one at a time, just like we were pushing push buttons. You see they're all running. I can stop a conveyor by toggling the stop bit. See, it has no effect on the rest. Or I can stop the whole system by toggling the bit. And when I restart it, those conveyors don't start back up that were running when we stopped it. In the manual, I showed you another way to do this. Another way to do this stop push button. I suppose that since I showed you 2 ways, that I should change that on at least one of them, or both of them, here. In other words, I changed this rung to look different. So I'll double click on this rung to edit it. And see, we've got stop conveyor 2 push button, true if off, and we have the timer. Then we went down a branch level. Stick with me here. We pulled the timer timing pulse down here, and we did an OTE instead of using latches. So we delete that branch. Do as I do, not as I say. Okay, that's how it was supposed to be. Because I'm looking at this and I'm thinking, well, how can that work? That doesn't make any sense. Well, that's because, you know, I looked at the manual here and I duplicated what I thought I showed you, but I didn't. that was a true if on. So I'm looking thinking, well, how can that work? Well, now it'll work. That's to stop conveyor 2. We'll go down, we have system enabled, and we'll start conveyor 2. That goes on and back off. You didn't see it though. Now we'll use our new logic. Toggle bit. See, it goes off and then this comes back on. This replaces this. This has 1, 2, 3, 4, 5, 6, 7, 8 instructions, because this is an instruction and that's next branch, branch start. So actually it's 1, 2, this is branch in, 3, and then 4, 5, 6, 7, 8, 9 instructions. This rung has 9 instructions, whereas this one has 1, 2, 3, 4, 5, 6, 7. So it has 2 less instructions, which means it executes quicker. Okay, I changed both the stop for conveyor 2 and conveyor 3 to the simplified logic. I think it's even easier to follow than this. I think this is less convoluted in appearance than this, because this starts with the done bit, whereas this starts with the stop conveyor push button being pushed. This starts a timer, this interrupts this. This is timer timing not true. This is going to be true all the time, except when you do this. Just to demonstrate that, let's make this 2 seconds. Now I'm going to see, this is true right now, and that's keeping that bit on in memory. Your normally closed button, that's what's simulating it, is this not being in the timer timing mode. So if I toggle this, the timer starts timing, and this stayed false for 2 seconds and then went back on. Again, it would work if it was 1 millisecond or whatever. So we'll make it back to 200 because we don't want to slow down this process. From that point, I had you testing, and I did state that since the other logic simulates an operator pressing and releasing momentary push buttons, we keep the logic separate. We keep this logic separate and we operate it from here. If we're going to start and stop, toggle that on, toggle that on, toggle that on, and we can toggle this off. It doesn't affect the other two, but if we hit the stop system, everything stops. How many push buttons are you simulating in this exercise? Well, it's real easy. You can count the tags that have the PB after it, right? Now, if the tag's used more than once, be careful not to count it twice. So you've got start and stop, that's 2. Start and stop for each conveyor, so that's a total of 8 push buttons. Toggle the stop system push button. Does everything stop? Yes, it does, because when the system enable, when this goes off, all of these rungs go false and drop out the motors. Just for fun, we used 2 different approaches to simulating a normally closed momentary push button. In the resting or normal state, a normally closed push button is closed. The contacts are closed, completing the input circuitry for this field device. Hence, that bit is on in the controller's memory in the resting or normal state. And this you can see in the manual. There was a little diagram of the logic marked A, B, and C. Keep this firmly in your mind as you look at this logic. And as you're looking at the logic, the stop conveyor 2 push button bit memory is on. Therefore, this instruction is false. A. When you toggle bit stop conveyor 2 push button from your keyboard, it flips the state of that bit to the off state, making that instruction true, and thereby executes the TO1 instruction. For the duration of this instance, stop C2 pulse of the timer data type preset. For that length of time, the timer timing bit is on because the timer is timing. Hence, the true if off instruction addressing the timer timing bit is false and sets the bit stop conveyor 2 pulse off for the length of the preset. When the timer is done accumulating, the timer is no longer timing, and the timer timing bit is set to off. The bottom branch goes true and holds the state of the normally closed push button on, not pressed, until you toggle it again. The only thing left to do just for fun is to test your logic. Play with it, change it, alter it. This is just for fun. This was a challenge. And then it says save your project as beginner LXX for your controller number fun3. Well, you can save it as fun3, or you can save it as we did, challenge part 2. So I'm going to save it as, because I made changes, I'm going to do a save as, and then I'll do a 2 here, part 2, piece 2, or version 2. I didn't have to upload the tags, but I'm in such a habit of just click, 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 click. Happy fingers on the keyboard and mouse that I saved it. Now in the manual it says, how many instances of the timer data type did you create? Well, that's pretty easy. You look at you had a start and a stop for 4 different push buttons, so that's 8. Within those instances of timer data types, how many of the members did you use? Well, we used the timer timing bit, we used the done bit. If we go back to the logic up here, scroll all the way to the top. So we used timer timing and done, timer timing and done, timer timing. And here we didn't use it. The done we did here, but not here. For the system pulse, we use the timer timing and the done. For conveyor 1, we use timer timing and done. For conveyor 2, we used timer timing and that was all. We didn't use done. So it depends on how you left your code, how many you want to answer here. But you see how we counted them. Basically, we use the timer timing and done for system and for conveyor 1. But for conveyor 2 and 3, we only use the timer timing pulse. And then here it says, which members did you use? Well, we just stated. Save your project, and we're going to move on to the next lab.